Welcome to another Nonsense Wars production. This is a 1/48 scale model of the SR, or Bulleid leader, named after Oliver Bulleid, the chief mechanical engineer of the Southern Railway at the time, and also responsible for other notable British designs like the Q1 and the Merchant Navy. One of the more famous but less successful examples of quote-unquote advanced steam locomotives, the leader coupled two 060 tank engines to a single boiler and wrapped the whole assembly in a contemporary-styled cowling with the intent of making a diesel-like engine. Nonetheless, despite innovations like chain drives in place of connecting rods, the leader proved too unreliable for regular service, and only one was completed and tested before being scrapped in 1950. I've always been a fan of advanced steam designs, especially the quirky ones that don't look like normal steam engines, such as the Leader or the Ace 3000. I actually built a model of the Leader way back in 2005, but it was an inaccurate, non-scale model, and thus something I wanted to revisit. The first opportunity came when I decided to build a 4.5 volt scale model. The locomotive would need to pull the tiny 2-axle battery box, a much more British looking than American looking unit, so the Leader seemed like a good choice. Unfortunately, the 4.5 volt Leader ended up the victim of not enough testing. The final product proved too heavy for the drivetrain setup, and the problem as a whole would not be easy to fix. Thus, my 4.5 volt engine became the S100, and the Leader sat on the back burner for a while, waiting for the appropriate power source to show up. With power functions being replaced by powered up, I took the opportunity to buy a handful of M and XL motors from Lego before they became unavailable. Happily, the XL turned out to be the right motor for the Leader with the perfect blend of power and size. Now, the Leader looks huge, and in fact it is. It is longer than the U-30B, a mainline American locomotive from 20 years later, though it is lower to fit the more restrictive British loading gauge. That being said, my decision to alternate between studs up and studs out construction automatically makes the internal space mostly 4-wide, greatly limiting drivetrain design, though not because most Lego electrical components aren't 4-wide, but because there isn't additional room for structural elements. Initial prototyping for a power functions conversion suggested that a more traditional dual M or dual L motor setup would not fit without excessively unconventional placement of the battery box or receiver, but I found a feature in the bodywork that would allow the use of a single XL motor. The front of the engine, the side with the smokestack, is pure studs up with 1 brick thick walls, such that the XL motor comfortably fits after a little bit of modification. I was also curious about the performance of a locomotive driven by a single XL motor, nominally equivalent to dual M motors, as I had not tried it before. A different approach to dealing with the limited internal space would be to integrate the drivetrain with the body, but I personally felt that it is important to be able to separate the two for maintenance and debug. All that being said, the drivetrain is pretty simple. The XL motor drives the front bogie through a set of bevel gears, which then turn another shaft connected to the rear bogie. Everything is geared at 1:1. The sleeves on the shaft try to prevent them from rubbing against the wiring, which has to run in the same space. The battery box hangs on the underside of this assembly, and it's a little bit difficult to access the power button, but as a trade-off, the receiver can come out through the coal bunker, and the IR visibility is not bad for once. The framing inside the shell is pretty messy. I tried not to fill in the load-bearing, non-visible parts of the construction in order to save weight while still maintaining structural integrity, but clearly it wasn't enough to save the 4.5-volt model. The curved and angled parts of the exterior are not particularly sophisticated. They are mostly just bits hanging off hinge pieces, etc. My biggest regret is being unable to accurately model the sweeping curve on the bottom edge of the cowling. The bogies are too big and have to pivot too far and would collide with an accurate curve. On the topic of bogies, they are actually the most unusual part of this build. Jay came up with this idea many years ago, and I kept it in mind for the leader. The bogies are articulated with rotationally symmetric halves, matching the rotational symmetry of the leader's chain drive covers. Compared to a rigid frame, this design allows for flanged drivers across the board and reduces the coupling angle in curves. The bogies and therefore the inner frame are built studs down because I needed the round side of the turntable to clear the clips behind the wheels. Ultimately, perhaps all this additional complexity was not worth the trade-off, but the articulated bogies were an interesting concept nonetheless, and I wanted to try it out. Performance of the engine is satisfactory. There's not much that can be said there. The speed range is unremarkable, and it will run smoothly at basically every notch. The unit is quite heavy to the point that I am currently not using tires on the power drivers, and it so far has not proven to be a problem. The locomotive doesn't quite have enough tractive effort to pull magnets, but it has enough to pull most practical loads. The leader's running weight of 904 grams is second only to my U30Bs of 1038, and that uses AA batteries. Finally, the main operational gotcha is probably the wide overhang of the body, especially on R40 curves. the pivot on the bogies can't be centered due to the articulation, and they have to be toward the center of the locomotive in order to accommodate the motor and receiver at the ends. On that note, this is the end of the commentary, so have a nice day.